Assalamualaikum warahmatullahi wabarakatuh. I'm going to present QMT342 project on Ayam Gepuk AG Tanah Merah, Kelantan. I will introduce my group members. First, me, Antasha binti Azhar. My ID number 2021867864. Next, Muhammad Mahdi bin Ahmad. His ID number 2021882626. Next, Muhammad Syamil bin Zamri. His ID number 2021467344. Next, Muhammad Salman Al-Farisi bin Abdul Aziz. His ID number 2021452888. And the last one, Raizan Adit Afan bin Hamzan. His ID number 2021207828. The location of Ayam Gepuk AG, Lorong Harmoni 3, Tanah Merah 17500, Tanah Merah, Kelantan. The operation time 11 AM to 10 PM. The observation time that we go to Ayam Gepuk AG is 2 PM to 3 PM. The number of server is 1.
Next, arrival characteristic. The calling population is infinite, meaning there are no limit to the number of customers that could potentially enter the system. It sets the stage for a dynamic and ever-changing queue. Next, the pattern of arrival follow a random process adhering to the Poisson distribution is an average rate of 21 customers per hour. This statistical model helps to understand the unpredictable of customer arrival over time. Adding a human touch to the model, our customers are patient. They are willing to wait in a queue without abandoning the system if the service is currently occupied. Understanding customer behavior is key in designing an effective queuing system. Moving on to the waiting line characteristic of the system, let's explore two key aspects. Firstly, the length of the queue is unlimited. There is no cap on the number of customers that can wait in line. This means that Ayam Gepuk patron can continue to join the queue even if it becomes very long. It's determined to the dedication and popularity of our service. Secondly, when it comes to serving the customer, we follow the first in first out queue discipline. This means that the Ayam Gepuk customer who arrive first at the payment counter is the first one to be served. It ensures a fair and straightforward process, respecting to the order of arrival for each customer.
Next, I will present to you about the service facility characteristics. In the restaurant Ayam Gepuk AG, it operates as a single channel system with one server, indicating that only one customer can be served at any given time. Additionally, the system is structured as a multi-phase system, signifying that customers progress through distinct stages during their dining experience. This phase could encompass order placement, payment, and food pickup. Furthermore, the waiting process is streamlined with a single waiting line, where customers queue up irrespective of their specific phase or service they are seeking. Next, I will tell you about the pattern of the service time. The exponential distribution for this restaurant is the rate at which customers show up is 55 per hour on average. This distribution helps us understand the time gap between one customer arriving and the next. Next is basic queuing system configuration. Restaurant Ayam Gepuk AG use a single channel and multi-phase system. The flow is when the customers arrive at the restaurant, they will join a queue before placing their food orders. Upon reaching the counter, a staff member will assist them in placing their order. Subsequently, a queue number will be assigned. After a brief wait, the customer's queue number will be announced, signaling them to collect their food.
Okay, next as for result. queuing model. Since IamGopa has single channel system, we have S equal to 1 server, and lambda we have 21 customer per hour. As for mu, we have 55 customers per hour. Average number of customer in the system. By using the formula L equal to lambda over mu minus lambda, we have 21 over 55 minus 21, we have 0.6176. As for average number of customer in the queue, by using the formula LQ equal to lambda square over mu multiplied by mu minus lambda, we have 21 power of 2 over 55 multiplied by 55 minus 21, and we have 0.2358. Okay, next is average time a customer spends in the system. By using the formula W equal to 1 over mu minus lambda, we have 1 over 55 minus 21, we have 0.0294 hours, which also means 1.76 minutes. Next, average time a customer spends waiting in queue. By using the formula WQ equal to lambda over mu multiplied by mu minus lambda, we have 21 per 55 multiplied by 55 minus 21, we have 0.0112 hours, also means 0.6738 minutes. Utilizing factor, lambda over mu, we have 21 over 55, we have 0.38. The last one, percentile time. By using the formula P0 equal to 1 minus lambda over mu, we have 1 minus 0.38, and we have 0.62. As for the percentage, 0.62 multiplied 100, and we have 62%.
Now I will teach you how to solve queuing system by using QM window. You need to open your QM window and click waiting line and choose the first one, because our queuing system is single channel. Put the title. We name our title queuing system at Ayam Gepuk AG. The cost analysis is no cost, and we need to click OK. We insert the value of lambda is 21, mu is 55. Next, we need to choose time unit. For us, we choose hours. We need to click the solve button. Now we can see the output. That's all.
So for the Ayam Gepuk queuing theory project, we have come to the conclusions. Here are some comments of the number of servers provided in the customer waiting line. The first is, the number of servers of Ayam Gepuk is adequate because the customer waiting line is less than the arrival time. The customer are also happy because they do not need to wait long before being served. From this queuing theory project, we also have gained experience on how waiting line happen in real life. We also learned that how a poor service would lead to an increased time in the waiting line. We also have a conclusion that if the average service rate is greater than arrival rate, then customers are served at a faster rate than they arrive. And if the arrival rate is greater than service rate, then queue will expand and the service will be slower. Thus, make the customer less satisfied with the service.